should do. Can I zoom in on here? Yeah, there we go. Oh no. I think that's pretty good. Give it a minute for some people to turn up. Let's turn on the matrix. La di da di da. Into the matrix. To YouTube. If I go on YouTube, I'll actually be able to see the chat. See if anyone's actually turned up. I might still be talking to myself. Your videos. Hopefully it's in here. Live. Fingers crossed. Here we go. If anyone's out there, welcome to the stream. Hopefully this episode will cover how ants move about. Oh man, what am I doing? Okay, I think. Come on, YouTube. I don't want any noise in it. Yeah. Why is it sideways? Let me just unsideways it. How do I unsideways it? Oh, no, what have I done? Oh, I could just turn it, I guess. As long as it's got the screen in it. Okay, I think. How's that? Ah, I can see the chat. Hello, Rain and Anki and Rushton. Welcome to the chat. So, okay, give me a minute. I'm going to try and spin it because I just don't like it like that. I don't like it. Got to flip again. Rotate device. No, I want to rotate the video. Okay. Turn the camera. I've turned the camera, Sadie, but it's gone sideways. I'll make sure my rotation's on. Yeah, the spin on the phone is on. I'll quickly go to home and then back. Okay. What I'm going to do is quickly. Oh no, I shouldn't have pressed that button. Okay, I'll just turn the camera like that. There we go. Sorted. Wiggle everything about. I've got my Hoover. It's just talking about Hoovers. Yeah, I can see the chat now. Turn rotation off. Oh, on the phone. Okay, I'll turn it off. I don't think it helps. Right, now we're just okay, let's do some learning then. Well, I think I got some pictures here somewhere as well. I'll have to Google them. Oh, there's the mouse. We need that. I don't have a mouse mat though, but it's alright. So, turn rotation off. Yeah, it was on, the rotation, but yeah, I turned it off and it didn't help either. So I think it's just really grumpy. Can't get a bit bold up there. So, ant legs. Ants are pretty much like humans basically with their movement. Although they do use a little bit of hydraulic action just to prop themselves out. But kind of like us, to be fair. So we'll start with like an ant leg. This isn't actually an ant leg here, it's a grasshopper leg. Let's zoom in a bit. Go away you. Don't need my email there. So basically, yeah, say this is a human arm. And it's like got your top muscles for pulling it up, bottom muscles for pushing it down. And your inside muscles as well. They're going to be stronger because it's just more work, maybe lifting up your arm than putting it down. And it's likewise in an ant. So basically, each little joint in an ant has one muscle down the back and one muscle down the front, except for their hip joints, or would be their hip joints, as they've got side to side movement instead. But they do use just little muscles really, which are attached to little spurs inside of the exoskeleton, and that helps them move around. I'll just check the comments as well. Maybe I'm going too fast. Sorted. So yeah, am I making sense? I hope so. But yeah, each ant leg is basically a lot like a human arm kind of thing, except the muscles are more, instead of being here and here, linked with cartilage or tendons and stuff in the middle, it's more the muscles are kind of here to here, so they go around the joint more, just kind of pulling it and pushing it closed. The fluid does help to push the legs out a bit, which is why when they die, you'll notice ants curl up, and that's because they lose their outside muscles relax, but the fluid also kind of gives way after a bit, so it loses the pressure, and the stronger muscles, they pull everything closed, and that's why ants curl up. Although it does do quite a bit, the hydraulic action, as I can show you with one of my experiments. Let me just pull it out of the cupboard. There it is. So I don't know if I'll be able to show you it. Get it right up to the camera. Okay. Don't know if you can see it. Side of my finger in a minute. Okay. Oh, you can't really see it, but in my hand I got a dead queen ant. It's so hot. Oh my god, I'm just useless. I'm watching the stream on TV, and I should just watch the phone. But I'm going to put this dead ant inside of a syringe, and you're probably thinking that's really cruel, but she's dead already. And for the sake of science, it's like, yeah, she's dead, so she ain't gonna feel anything. But let me line it up with the camera. Okay. Oh, please focus. Can I do anything about the focus? Maybe. If I hold it at the right distance, maybe. But yeah, see what happens. It's well hard to see, isn't it? I keep pulling it back and forth, but you might be able to see that the queen's body is actually moving every time you pull the syringe, because it lowers the pressure. It does pop her legs out a tiny bit, but not much at all. So yeah, you can kind of tell it's not pneumatic. If you put a spider in there, it would fully expand out, as spiders use a lot more not pneumatic, hydraulic fluid in their joints. So yeah, oh, it's finished. But yeah, so basically ants, they've got muscles, and they use those for wiggling all their joints. That goes for pretty much all of their joints. They do have some special muscles though, where basically they can be controlled by one nerve, but one input doesn't mean, like, say in our arms, if we tell, like, close your arm, one kind of input from your nerves does one job, whereas some of these muscles in the ants, they can also do lots of things from one signal. So if they're told, like, one signal, they might do like 4 things, and those are quite useful in the wings and places like that, because ants' brains and nervous systems, they're not actually very fast. They're, I don't want to, ants are a little bit dumb in some ways. Well, no, they're just slow. Ants are a really good operating system running on a really bad computer, but their nerves can't fire fast enough to actually make their wings flutter. So what they have to do is send one input into the nerves, or into the muscles, and then those muscles will react 4 times to that one input. Although it could be anything between like 1 and 10. And then let's have a look. If you haven't gathered yet, we're learning together, because some of this stuff I haven't got a clue. So what do we Google? That's a good question. One nerve input, multiple muscle spasms, ants. This is not what I'm after. Oh my god. It's all for humans, I don't care. Okay, let's put movements maybe. Oh, what's this? No, this is not the one. Mandibles use the normal method. We'll just go for insect wing muscles. Here we go. How can we go a bit further? Let's have a look in the chat. Hello all you new people as well. I should go through them all. We've got Ants England, Le Formish de Genlu. I probably masked that. Anti-enclosure. Rural Ants, hello everyone. So yeah, if anyone's got any ideas what I can Google to get to find out what the wing muscles, how do you Google what is one input of a nerve and multiple spasms of a muscle? Insect wing muscle nerve input. Oh, look at that. Let's have a look. Not flight muscles. Aha! Now this looks promising. Drosophila. I think that's a fruit fly, that is. The precision of motor commands is highly relevant in large. What we got? Okay. God, this is so long. I'm not sure if I'm going to be able to find it in here. Over here, we've got quite a good one. This should be quite similar. Got anything? No. There's the brain. And brain goes down. I think that's a chemical receptor. I haven't got much of a clue. These are the wings. Yep. It's not really relevant. Aha. Here we are. In insects, flight muscle precision and efficiency are crucial for flight control because of wing stroke frequencies ranging from 5 Hz in some butterflies to 1000 Hz in certain midges. The need for relatively small modification in wing kinematics during maneuvering flight. Oh, this is tricky now. Okay, it's probably here. Well, basically, I can't find it, but there is a special word for when an insect can send one nerve input or output to a muscle, and the muscle will do multiple things. What I'll do is I'll stick the link to this page because there's a good chance it is actually mentioned here because it's a good in-depth look at fly wings. But some ants, because you probably all know that elates have wings, so they need to fly and they need to move their wings a little bit faster than their brain can actually tell them to move. So they have little systems built in just to make that happen a little bit faster. What else have we got in movement? If anyone's got any ideas or questions. Yeah, anyone got any questions at all? Trying to think of it's like quite simple really. Ants. They are just like us, but instead of the muscles in the middle of the arms, the muscles are here. That's it. What else? Let's get some little pictures up and maybe someone will turn up. Here we go. This is a nice little one. Oh, you can tell, spiders, basically a spider leg is just a rod and a rod. There's not much to them really. They might have a little foot at the end, but there's nothing really to them. Whereas ants, because they don't use purely, well not purely hydraulic action, spiders do have muscles, they're just normally one-sided. But because they have the option to do all their movement via muscles, they can also have extra appendages on their limbs. So the ants, here we are, like a spider, it can't really have a tibial spur that kind of works because they can't wiggle it with their hydraulics, because if they say they wanted to deflate the tibial spur, this tiny little bit here, they'd also have to release the pressure of their tarsus or equivalent of the spider. So that's why spider legs are just simple, because yeah, if you deflate it, they all go floppy, and you can't really use, like say you wanted to put one finger down and you're a spider, all your fingers would go down. But ants, oh, they got the power. Oh, that'd be great if you can hook me up with that paper. Chuck it on the Discord or something. For me. I'm not even going to try. Delglen. Yeah, what else have we got? Let's go into a little bit of what makes an ant as well. One of the things that makes an ant is the petiole. And that's quite an important bit. All it really does, I believe, is lets them turn around so they can sting their food. And yeah, but that's one of the little things that ants have. It's an ant thing. What else? I guess you're kind of wondering as well, where does the pressure come from to keep their legs a little bit inflated in the beginning? Basically, in their, I do believe it's in their gaster, ants have a little heart, which it's not like our heart where it's closed valve system. It's just like a floppy tube, and it just like flops around and contracts and wiggles, and it just slowly pumps everything around, but it does keep a little bit of pressure in the system, so the legs are a little bit inflated. Oh yeah, Angie Rushton just saying his lassies has tucked their gasters in. Yeah, that's with the power of the petiole. I do believe some ants, like Myrmica rubra, they've also got the spikes, which point out the back, and I kind of think maybe that's a defensive thing, so when they're stinging, say they were in a fight with some Lasius niger or something, they would have little spikes to stop the Lasius niger biting onto them while they're curled over stinging, because they're a stinging ant. Whereas the Lasius niger, they don't have little spikes, because they don't really sting too much, they're little nippers, so they don't need defensive spikes that pop out the back of their petioles, or their thorax as well. Yeah. Hey electric ants, welcome to the chat. Has anyone got any questions on ants as well? We could do like anything, to be fair. Yeah. I'm just kind of testing the water this episode. Oh, inbreeding. Oh, I might be able to get some good pictures up too. But there's well, you got accidental inbreeding. That's just inbreeding DNA. We'll go for humans because accidental inbreeding is just like for kind of humans inbreeding. I don't know if it'll show it. There we go, this will do as a picture just for the illustration. But say they're brother and sister, and yep, they just merge nice. Well, they don't merge nice. Oh, Jesus Christ. Okay, scrap that one. That was too human. It's messed up when you're talking about inbreeding and it's humans, and it's like, yeehaw! Where's that place in America? Is it Texas or something? So yeah, basically though, some ants, if they're accidentally inbreeding, they'll literally be bolting together like the kind of same chains of DNA from their parents, putting them back together, and yeah, that's kind of detrimental when it's that type. Although you do have the other types of inbreeding as well, and there's a couple. I can remember one right now, and the other one will probably come to me in a second when I'm talking about this one. But you have clonal inbreeding. So basically, you got the queen, and instead of actually using any of the male's DNA to make her queens, she'll literally just clone herself, like clone her female DNA into the new queen, and that queen is then an exact clone of the mother, and the father will be the other half of the genes, and he'll be an exact clone of the father's sperm. So basically the queen is able to make a female worker out of what is essentially and would normally be like an infertile egg. It's a clone of her, so it has none of the male DNA really. And they're basically kept separate, the two gene codes, so they don't actually mix. So although the queen and the male could have come from the same colony, they are not really related at all. They're two separate families, and yeah, they can't really even inbreed. They're just basically, I'm not really sure why they're there, to be honest. Basically to propagate the species and mix it up a tiny bit. But because it's all clonal, it's, yeah, why do they even need the mates? Just keep cloning the females and you'd be sorted. Oh, hey Elijah. Oh no, last year's flowers don't have stingers. Yeah, as Rain said. They do have acidopores though, which are basically just little pores in their butt that can give out a little bit of acid. Although, nah, they don't really do anything. They're useless. We were talking about something as well, weren't we? Oh, the inbreeding. What is the other type of inbreeding? You got accidental. You've got clonal. Oh, and then there's like inbreeding that isn't really fully inbreeding, I don't think. Some ants, like with multiple queens per colony, say the brothers of one queen will hook up with another queen's females, and it's in the same nest, so it's semi inbreeding, like, but it's more breeding in the nest, and yeah, they'll hook up, and that can keep going for quite a while. It's quite sustainable, but eventually you'd need a little infusion of extra DNA. But that doesn't involve any cloning that way, and you still get a little bit of a mix. An asexual species of leafcutter. Oh, that's Googleable, that. We're going in. Asexual leafcutter. And all significance. The fungus seems is to be asexual, which makes sense. So, I'm gonna need more information, Lige. But yeah, that's quite interesting though, and it's kind of yeah, no, it seems pretty obvious. It's kind of ruined poor Hood's idea that, well, I think it turned out to be poos on the fungi for the little flowers, but basically leafcutter fungus it hasn't actually been inbreeding. It's just one fungus, and it's just grown and grown and grown, and it's never mated or any sort of thing like that. It doesn't reproduce like that anymore. It just grows bigger and bigger without ever sexually reproducing. That's pretty cool. That it kind of makes sense though that, yeah, if you're a little fungus and you're in an isolated nest, then you're not really going to get much opportunity to mate with another fungi. So you would just keep cloning and just grow. What else we got in there? Oh, any anatomy questions? Well, let's find out what the little spurs are called inside of an ant. Like inside of the exoskeleton, they have little spurs that the muscles anchor onto. Hopefully. Internal spurs. Waterproof. The exoskeleton, blah 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 blah. At the end of it is a spur. Ooh, ants have an internal skeleton as well. Now we're talking. Like, ooh. Well, I guess, is it a dual kind of like plywood with an internal layer layered onto the external layer? So anybody likes this bit. Oh no, I've lost it. No, that's neurological. Okay. Morphological terms. Mobility. We don't need them. Oh, this is some good pictures. We should go through this in a minute. Abdomen. No. Be down a bit. Here we are. Epidermis. Endoskeleton. As well as an exoskeleton, ants have a small but significant endoskeleton. That's an internal skeleton of sclerotized internal plates that serve as muscle attachments. These are the things. But I don't think they also have a different name that isn't sclerotized internal plates. The endoskeleton of the head is the tentorium, formed from the united anterior and posterior pairs of arms. In ants, the fusion is complete, and the temnotorium, or tentorium, takes the form of a pair of longitudinal struts attached to the head capsule anteriorly and posteriorly. I think that means like it's either top to bottom or front to back, or something like that. That one, or front to side, and yeah. The only visible external indication of the tentorium are the anterior tentorial pits and posterior tentorial pits, which mark the points at which the anterior and posterior tentorial arms attach to the exoskeleton. Oh, so basically they've got like struts, like inside of them, the ants. I think that's, yeah. So you have the exoskeleton, and some of it is like they got struts. At the internal junction of the mesothorax and the metathorax. I think that's like here and here on you. Just posterior to the mesocoxal cavity is a raised ridge with low walls. Blah, blah, blah. 2 seconds. Ants have got an internal skeleton as well as an external skeleton. That's pretty cool. What we got here? Oh, yeah. Oh yeah, he just joined a bit of a science lesson. Blodwyn. So, yeah, what do we got? We might be able to... is that it? No. Epidermal. No, not epidermal. Erect refers to a hair that stands straight up, or nearly so, from the body's surface. I like ants. That's simple. Let's find oh, dentate. That's ants' teeth. So has anyone got anything they want to know? Oh yeah, we got Mycosepurus. Oh jeez. Ah yes. I've already googled it. Lovely. Let's have a look here then, see how their reproduction goes. Password descriptions. Keys. Identification. Generally I'm looking for a bit on asexual reproduction. Biology, that's what we want. Mixed mating swarms. Well, basically, they don't hybridize. Although, according to this, it does seem that they can do kind of normal sex. But yeah, they are asexually. They do have an asexually reproducing fungus. They. Wait. Yeah. Ah yes. That's weird. Wait a sec, this one's a tricky one. So they have flights, and the colony is comprised of a single ant clone, tending a garden with a single fungus clone. Oh, that's pretty cool though. These is it? I've forgotten the other fungi farmers, Myrmecocephalus. Probably said that wrong. But basically, these ones actually do mix up their fungus, which is quite cool. So instead of sexually reproducing the fungus, they will take a little bit of their fungus from one nest and take it to a completely different nest to mix up the fungus DNA. Well, not mix it up, but kind of as time goes on and they split apart, they will have a little bit of variety, and slowly, of course, they'll evolve the fungus. And this way, they can ensure they've always got the best kind of seeds for the field. But let's try and make sense of these clones. Oh yeah, here's some bits about the microbial communities in Smithy. Not being homogenous basically means they're not all the same, they're all mixed. Because they've been sharing. I'm trying to make sense of this clone though. Oh, I think I get it. So basically there's 11-ish different queen types at the minute, but yeah, if they're going to reproduce, they just make a clone of their queen and send it off. So basically there's 13 or 11, here it is, 11 different ant clones where they were looking in central Panama. So, but there could have been 100 nests, but there were just 11 different genetic wise ants. What's my least favourite type of ant? Fire ants, then Solenopsis, Geminata, and Invicta. Basically, if you get them, like you should everybody, if you see for sale, you should buy them, and then get them home. And if you light a good bonfire, a real big bonfire, put them on there, because fire ants really love fire. That's why they're called fire ants, because they just love fire more than anything. And there's nothing you can do that'll make them just be the best colony you've ever had, except chuck them on a fire, because they just love it. So yeah, I'd highly recommend getting fire ants and putting them on the fire, because they just love it. Well, that's pretty cool, Elijah. Titanomyrma gigantea was the largest ant thought to have ever lived at over 5 centimeters long. Somewhere I've got a ruler as well around here. I saw it. Where's the bloody ruler gone? There it is. 5 centimeters. That's pretty big, that. So, yeah. Up to the second knuckle of my finger. So where can I get one of these queens then? Oh yeah, that's it, Elijah. That's what you got to do with your fire ants. House them in the fireplace. And if you don't keep your fire warm enough, say you let it go out, they'll all die. So you've just got to keep that fire going for as long as you've got the fire ant colony. And the moment you let the fire go out though, they'll die. And you'll just find like dead ants. But until then, they'll be loving it. Fact. Allegedly. I can get rid of the video maybe. Yeah, there's where you can do that with your fire ants. Put them in the oven for hibernation. Yeah. Top notch advice. Where's PJ tonight as well? PJ? I didn't really give him any warning. I just kind of did this as a spare of the moment earlier. I was like, oh yeah, maybe I should finally start learning how to describe ants. What else can we describe about ants? We'll just get some more pictures up. We're going for a lucky dip. Ooh, so I close my eyes. What have we got? Decumbent refers to hair or setae, setae, or whatever it is. Setae, setae. There's another word for hair. So they're both, yeah. Hairs inclined at 10 to 40 degrees from the surface. That's pretty cool. I'd say most ants, I'd say, are about 10 to 40 degrees maybe. Although, well, no, I'd say actually most are maybe 5 degrees. So maybe a decumbent ant, it'd be proper fluffy outways. Trying to think Menoporus bicolor, that'd be a good example. They're fairy little girls. Although they might be more than 40 degrees. Because some of their hairs look like they're coming out of between like 70 to 90 degrees. Oh, step on Hoover. Let's go in for another random thing on the old list. Gula. Use of this term when referring to the ventral surface of the head capsule in ants is incorrect. Morphologically, the gula is a separated medioventral sclerite of the head, which is bounded anteriorly to or by the posterior tentorial pits. Oh, we learned about these a bit ago with the endoskeleton stuff. So yeah, the medioventral sclerite of the head, that's going to be one of these weird little platey things that are inside their head. And it's bounded anteriorly. If there's any people that have recently done their science, they'll actually remember what that one is. but I think it's like, might be upright ways, could be front to back. In consequence, the posterior tentorial pits are distant from and considerably anterior to, and to the occipital foramen. Oh, I have a clue. Maybe what we should do is we could just start with, what the hell is a posterior tentorial pits? Let's go to T. Somewhere out there is someone that actually knows all this as well, because you don't just write this out of nowhere. Is it tentorial pits or something? Oh god, it's not it. Oh god. Let's get back to the chat. Like, get me back on thingy. Spiracles! I love spiracles. Check this out. I got the spiracles down. Here we got is this here in the background. That is your spiracle hole. Here it's got the fin plates on it, or the sieve plates. And the sieve plates just keep junk out of it, and they can actually close and open those. But in an ant, they're actually more under the skin. Right here. So you've got your sieve plates, you've got your valve, and there's also the, I've forgotten its name. But basically there's one muscle and a wishbone structure, and when it pulls, it bends the structure and it opens. I believe it goes that way. Although it may go the other way, so when it's relaxed, it opens, which allows the air to get into the tracheal manifolds of the ant, which then goes down the tracheal or trachea of the ants, then goes right down. These little things have special names, these little bits. Is it on here somewhere? No. These little ridgy boys are called cnidae, are they? Yeah. But these go down to the tracheolar cells. Oh, these are the little tubey bits are actually like a little cell that transports all the tracheolar fluid down into the target cells. Yeah. And that's just my background of me screaming. Oh, I wondered like how they hissed. I always thought maybe they were rubbing their wings together or something like that. I didn't realise it was actually the outflow of air through their spiracles. Yeah. Has anyone got any more questions? I think I'll wrap it up in a bit. Maybe like next time I'll get more little points to talk about. And more focused as well. Although I do want to know what the little spurs are called on the interior of the exoskeleton. What we can go in is ant head anatomy muscles. It should be here. Come on. Internal. That's pretty cool. Images. Where's the cut away the head? I don't know what we can do. Leaf cutter. I think it's is it an MRI? And heads. We'll go with MRI. I think it's a CAT scan really. Somewhere out there, some beautiful pictures of scanned ant heads. Oh, there's too many like stock photos for our website. Internals. Go with CAT scan. Oh, come on. Oh. Internal ant head muscle anchors. Oh, no. What on earth is that? Be interesting for one day. Ah, here we are. This is the boy. It's the one I'm looking for. I like this one. Oh no, what have I done now? Oh yes, they got head and legs. We got some more stuff to learn then. Back to lesson, back to lesson. Oh. Yes, we're gonna have to... Oh, go away, cookies. Results. Both the head and leg of Melistotarsus worker ants contain novel skeletal muscular adaptations to increase their ability to tunnel through living wood. Well, that's pretty cool. So this ant, what is it? Melistotarsus species of ant. They tunnel through wood, and to do it, they've got... Most ants have really strong, and same with most animals, we've got really strong bite muscles, but the actual muscles to open your gob are weak as hell. So you can hold like an alligator's like mouth shut with your hands, whereas you could never hold it open with your hands. But some species of ants, like this little Melistotarsus species, because they're tunneling through wood, they need to be able to push the sawdust and all that sort of thing out the way as they're chomping through. So they've got really strong opening muscles as well as closing muscles in their mouth. Also, they have the tip of the mandible is reinforced with zinc. That's a bit like leafcutter ant jaws as well. Maybe we could do a whole episode on mandibles, because you've got trap jaws, Harpygnathos, leafcutter jaws, little nipping jaws, slicing jaws. Yeah, all sorts of jaws. Blady jaws. Yeah. Yeah, mandibles. So search up hell ants. I think I've heard of them. The evil ancient ones. Oh no, these sound cool. Yeah, this is yeah, watch that bad boy. Reign of the hell ants. How big was a hell ant? Oh no. Oh no, it's just getting worse. I was like, why are they called hell ants? It seems pretty now tense or whatever they call it. Then it's like, how big was a hell ant? And it's like, oh, you're getting a bit past tense there. And then they just bloody spoil it there. When did hell ants go extinct? Roughly 65 million years ago, unfortunately. I better not press that. They'll get me on the old thingy. Here we are. The Smithsonian Museum. Hell ant. Was unlike anything you've ever seen before. Oh my god, yeah, look at it. It's like a stick insect ant. And it's got an uppy downy jaw or something. What's going on there? What are they going on about? Oh my god, that's cool. What? The 99 million year old ant had... Oh, shut up, Avast. Go away. I don't care if my IP address is visible. My face is as well. The 99 million year old ant had scythe-like jaws that swung upwards to prey, or to pin prey against a horn-like head appendage. So basically, like, they had like a horn on their head, and their jaws went kind of, instead of side to side, like normal ants, like it's all side to side, choppy choppy, they went up, and they had a thing on their head to hold it as well, so they'd pin it. Seems a pretty good idea, to be honest. I'm trying to think of reasons why like they would have stopped doing it. I guess when you've got your side-to-side jaws, you can use your internal mouth bits for maybe a little bit more. I guess if your jaw is made to go kind of upwards, you're going to block off your mouth a lot of the time. So you won't be able to kind of do your old trophallaxis as easy. It's a bit weird though, isn't it? So this bit here is the horn, and then the jaws would be underneath, chomping upwards. See if they got any more. Here we are. Look at this weirdo. Oh my god. Let's zoom in on these weirdos. So A. Number A. Hydomyrmex. Clypeal horn or no? Are these green ones extinct? I'm kind of thinking they're an extinct genus. Are you going to tell us? Yeah, look at these jaws. Like this jaw here, I think that's a bit like the one we were just talking about, but it's got it coming out the top, and then the teeth are a little bit like Harvignathos, to be honest. You've got your little jaws for doing all the work down here, and then your upward jaws pin the prey, or maybe not even prey. It could have been something completely different, because how the hell are we meant to know? It's 99 million years ago. We don't really have a clue. But this one seems a bit restrictive, because how are you going to get your food into like this little gap? It doesn't actually make sense, that one, for what's his name, for doing hunting with it. So maybe that one hooked it around roots or something and wiggled his head side to side to wear the root down and suck on the juice or something like that. This one here looks a bit weird. I can't really think of anything that'd be good for. Maybe they had lots more fights with each other so they could headbutt each other and like jab each other with the tips. Not a clue. This one here as well seems a little bit like this guy here. Seems a bit useless for holding prey. Is how you're going to get it in. Down here. Look at that one. That one looks kind of cool but a little bit wimpy. Although the head is like, the way it's got a dent in it is pretty cool. That one just looks like a messed up crab. Although there's a lot of videos and information as well on how a lot of things of lots of different animals from completely different like places, species and genuses, they all end up looking like crabs. So you never know, that could be the final form and what it's eventually going to evolve into. Here it looks like some more standard ones. I have no idea what G is. Aquilomyrmex, lovely name. No idea what those are for then. These are some, I believe they look more like living ants, to be honest. And the fact that some of them are more CAT scans kind of gives it away. Yeah, that's quite an odd shaped jaw. That looks like a chomper, but maybe chomping up seeds. Trap jaw, still about today. Your little chippy choppy. That was a bit weird, to be honest. But some ants have little jaws. Maybe it was a male. Leafcutter head electron microscope. That just gave us a nice zoomed up. And meat ants. I'd say leafcutter jaws are actually probably stronger. Let's see how much metal impregnation or whatever they call it the meat ants have. Because I know the leafcutters have basically got like lots of zinc in their cutters. I can't really see. I'd probably say a leafcutter jaw is. Well, you guess a leafcutter jaw is sharper, although the meat ant jaw may be stronger in actual kind of grunt. Let's go back. Here we are. Now I can read the chat again. But yeah, leafcutter jaws are sharper, I'd say. But most ants' jaws aren't actually made for slicing, because it's kind of like if you got chopsticks, you can do quite a lot of things with chopsticks. But if you try doing the same things with knives, holding them like chopsticks, it just won't work because you cut everything. And you've got to do some delicate tasks sometimes, like carry the babies. You don't want to be doing that with a gob full of knives. Unless you're Dracula ants. We can forgive them. Hey, you crazy antics? Long time, mate. Welcome to the stream. I'd say like meat is actually like weaker than leaves. Like if you had a piece of leaf, basically like a trunk of a tree, I guess is a piece of leaf that was as thick as your leg, it would pretty much be a lot harder and stronger. Yeah. And when like I guess both of them will only cut a little bit at a time, so yeah. Anyway, any last questions? I'll catch you in a bit, Bloodwin. I think I'll get off in a minute. Unless anyone's got any more anatomy questions. Trying to think of some last minute things I've forgotten. I don't know, but I do have some new seed feeders. Oh, look at that little mess they're coming out. Does anybody want to have a sneaky little, what's his name? Or Mystrium camele? It better not be a camel spider or something. Let's try that. There they are. Predators. Ooh. What you got? Carl, I got some cool jaws. Big, wide, loads of dentates or whatever they're called on them. Well, this is what I mean by learning together, because I kind of know some of the bits. Like these have a name, and that's like what I know. I don't know the name. I just know. Oh yeah, those little bits there have a name. But yeah, they are distributed in Indo-Malaya and Australia. From Australia to Brunei. Well, yeah, loads of places. Rich and varied species. So let's I swear somewhere it said they're millipede hunters. Oh yeah, millipede hunters. Yeah, they got some cool mandibles here. I guess if you're hunting millipedes, because they're round like a millipede, if you have your jaws quite tight together, you might be able to get a kind of glancing blow on the bottom, and maybe get lucky and grip onto the kind of half moon of the bottom. But you're not really going to get much grip. Whereas if you've got a good gap in the middle, and some long, slightly curved at the end ones, you'll be able to hold on to the millipede, and it won't be able to wiggle off as easily. And if you notice the little teeth, the micro dentines or whatever they're called, like loads of little teeth, they'll kind of dig in all over the place and hold it steady just for, yeah, it makes sense that these would hunt millipedes. Also, it looks like they don't have any eyes. Although a lot of worker ants don't have any eyes. I guess again, if you're hunting a subterranean millipede or the likes, they don't need any eyes. Oh, they have minute compound eyes. Yeah, they are absolutely minute. I can't even see them. I think that's it. Oh, they're little trap drawers, are they? Although these don't look like trap jaws to me. I don't know. I can't find anything about them being the fastest. Go for fastest. Mince the old. Mystrium. These strange insects have a structure of 200 miles an hour. Yeah. I think I get it. Yeah. Because there's so many different little types of these Mystrium camele. like all across like Australia and Asia. There's loads of different types. So the last one we were looking at was a different type. This looks like your more proper girl, although I don't know if this is camellia. What we got? Yeah. That looks more like a speedy jaw setup to me. Yeah. It's kind of a little bit varied, like that one looks a lot slimmer than that one. He looks a bit slimmer, that one. Let's see. They're cool. Little snappers. I know in the little snappers as well, they've got it well efficient. Like, so they got their little lock mechanism, and it'll have like two tiny little sometimes it's nerves, well not nerves, muscles, like holding it just a tiny bit shut. And one nerve will just basically the signal gets sent from the hairs, and it goes down like one or two nerves straight to the muscles which control the spasm which shuts the jaw, and that's how it's like so fast. And it literally is like one really long nerve, and that's pretty cool. That it's like it's nearly the size of their mandible. But that way they don't have to transfer the signal over any like ends in the nerve, so it goes even faster, so you can snap it shut even faster. So that's probably not that species. I'll catch you later, Lois. Got. Oh, hey, ramblings. I think I'm just about to end the stream unless you got any questions of ant anatomy. Yeah. Trying to think. I said some stuff. I've rambled on for quite a while. Yeah. Maybe I'll get a little experiment and give it another try quick. And drop the keyboard. Keyboard will be fine. I've dropped it like 5 million times. Let's have I gotta look at it through the phone screen. See if we can get it to move again. Like this 100% dead queen, but we'll use the pressure change to. Oh, you can kind of not see anything. Well, because the ant is in the syringe, it wiggles. Oh, don't worry, Paul. I think we've just like been rambling on. Basically, we started off with like ants have got muscles, and they're basically like us, with a little bit of hydraulic stuff. One bit you might find interesting though was if you look at an ant's leg, they've got like tibial spurs and bits like this, like extra appendages on their legs. And then if you look at a spider, no, they don't really have that because they use a lot more hydraulic stuff. So you can't really wiggle your little extra finger here because it will deflate the whole leg. So yeah. Whereas ants, because they got more muscular stuff controlling all their muscles, a lot more muscles kind of doing it, and a lot more muscles controlling their legs, they can have extra appendages without it like deflating their leg when they want to move it. Yeah. Any last questions? Just looking in. Oh yeah. Seed feeders are working. Top secret. Oh yeah, that ant space where they got like the antennal, like they're not called antennal outputs, but they should be really. You got then they had the thingies that look like eyes, and everyone was like, that ant's eyes look really evil, and it was just the antennal kind of anchor point where it goes into their head. And yeah, I thought it was quite a nice looking ant really. I didn't think it looked too angry. Like a lot of people were like, he looks so angry, and it's like, no, it's a pretty cool ant. Oh yeah, ants, they kind of hear with their knees and they hear with everything. So like they'll have little, like through their little hairs, and the hairs are sensitive. Or setae, as I like to call them in ants. A lot of them have got just little nerves just anchored onto the base. So as the hair wiggles, like because of any sort of movement, they just pick that up, including like voices in the air, like that'll vibrate the hairs, or pretty much everything does. And they can pick up all sorts, and some of them as well are like chemical receptors. Yeah. I think I'll wrap it up though, because I need to put me a cottage pie in the oven as well for dinner, because I'm getting hungry. But yeah, I hope you enjoyed waffling on about ants and ant anatomy. Until next time, peace out. I'll do Antscapes. Peace and love. Yeah. But yeah, I'll catch you all in a bit. Hurrah! Thanks for watching as well. See you in a bit. Oh, what do I press now? Do you want to stop streaming? Okay. See you in a bit.